Thank you very much. Thank you for attending our Cssc reception party in Athens. Since we start to hold the reception party in 2015, this is our third time to hold the reception party, and every time we select the September as a time. We think this is a good time for our back to work because we have a very, very good summer holiday and every people enjoy their free time, and then you have a concentrate and you have dominated back to the hard work. Although we are shipping men is always working day and night. So we are stuck. And now we open the reception party. So welcome to our Cssc President, Group President, Mr. Yang Jinchen, to make the speech.
女士们、先生们、朋友们，大家晚上好。
Ladies and gentlemen, dear friends, good evening, everyone.
9月的希腊，金风送爽，秋色宜人。在这美好的时节，很高兴我们在这里欢聚一堂。今年是中船集团第3次在雅典举办推介会，非常荣幸能在这里向各位来宾和各位朋友们推荐中船集团的最新船型。
September has just set in Greece, bringing with its refreshing breeze and picturesque autumn scenery, and we are so delighted to have all of you with us in this lovely season for the reunion of 2019 Cssc reception.
首先，请允许我代表中船集团对各位嘉宾、各位朋友们长期以来对中船集团的支持和信任表示感谢，同时对各位的到来表示热烈的欢迎。
First of all, please allow me, on behalf of Cssc, to express our gratitude to all the distinguished guests and friends for your long-term support and confidence of Cssc, and to extend warmly welcome to all of you.
20年前，中船集团正式成立，中国造船业处于发展起步阶段，全国造船产量仅占全球造船产量5%。
Cssc was established 20 years ago. In the meantime, Chinese shipbuilding industry was in initial stage of development, with the national shipbuilding output accounting for only 5% of the global.
经过20年的努力发展，中国已跻身世界最主要3大造船国之一，全国造船产量占全球产量的36%。中船集团也不断壮大，发展成为世界一流造船集团。在这里，我首先要感谢一直以来支持中国造船和中船集团发展的希腊船东们，也要感谢船集社和各位中间商一直以来对我们的帮助和支持。
After 2 decades, China has become one of the world's top 3 shipbuilding nations, accounting for 36% of global output. Cssc is developing into a world-class shipbuilding group. I would like to thank the Greek shipowners, the classes, and the brokers for long-term support.
创新是发展的动力。中船集团在努力发展自身的同时，始终将创新作为重要的企业发展要素。
Innovation is the driving force of development, and Cssc has always taken innovation as an important factor of enterprise development.
中船集团在新造船、船舶修理改装以及船舶配套产品领域不断取得新的成果，将中国造船业由制造向制造转型。
Cssc makes new achievements in the fields of new building, ship repairing and retrofitting, and ship equipment industry to upgrade Chinese shipbuilding from manufacturing to intelligence manufacturing.
在新造船领域，中船集团的产品结构持续优化升级，组件产品从散货船、邮轮和集装箱船，拓展至 LNG 双燃料超大型集装箱船、超大型液化气船、液化天然气加注船、豪华客滚船、极地零稀油船、FPSO、FSRU、 等高技术、高附加值船型、绿色环保船型。
In new building, Cssc continuously upgrades the structure of products. The main products used to be covered bulk carrier, oil tanker, and container vessel, and now expanding to green, high-tech, and high-value-added vessels like LNG dual-fuel ultra-large container vessel, LNG carrier, LPG carrier, and LNG bunkering, luxury RoPax, X7 condensed oil tankers, FPSO, and FSRU.
在高端改装和修理领域，中船集团也不断突破压水水处理装置加装、大型集装箱船储留洗涤塔加装、深柱船改装项目、薄模型 LNG 船货舱修理项目、豪华油轮修理改装等项目的顺利交付，奠定了中船集团在高端改装领域的领先地位。
In ship repairing and retrofitting, Cssc breaks itself while ballast water treatment retrofitting, scrubber retrofitting in large container vessels, cattle ship retrofitting, LNG membrane tank repairing, cruise repairing, and retrofitting and so on. These projects settle Cssc in the leading position of ship repairing and retrofitting.
在船舶配套产品领域，中船集团不断提升制造能力和研发水平，低、中、高速柴油机的全谱系、双燃料主机、辅机和船舶机电产品的系列化，赋予了中船集团更全面、更先进的船舶性。
In ship equipment industry, Cssc improves its manufacturing, research and design capability, acquires a more comprehensive and advanced shipping core through full series of diesel engine, dual-fuel main engine, auxiliary engine, and marine mechanical and electric products.
展望未来，绿色环保、细细化和智能化将成为未来船舶的主流需求和发展趋势。如何在绿色能源应用群获得突破？如何深度融合人工智能等数字技术，将是我们共同研究的课题。
Looking forward to the future, greenization, information, and intelligentization will become the common demand and trend of future vessels. How to achieve breakthroughs in the application of green energy, and how to deeply integrate artificial intelligence and other digital technologies will be our joint research topics.
本次推介会，中船集团将向各位展示我集团公司最新的研究成果，愿意与大家共同探讨未来船舶制造领域的健康持续发展。
In this reception, we see Cssc will present the latest designs, and we are willing to discuss the sustainability development of the shipbuilding industry in the future.
中船集团今后将持续以船东和市场为关注焦点，深化与船东的沟通与交流，进一步加强内部管理，加大研发投入，致力于为市场提供性能优良、质量上乘、价格有竞争力的产品，也希望能继续得到朋友们的信任与支持。
Cssc will focus on the market, deepen the communication, strengthen internal management, increasing research and design investment, and devote ourselves to providing products with excellent performance, superior quality, and competitive price. We sincerely wish to earn your trust and support.
最后，预祝本次推介会取得圆满成功，祝愿各位嘉宾、各位朋友们身体健康，万事如意，并度过这个欢快而美妙的夜晚。谢谢大家。
Dear friends, I wish this reception a full success and good luck to you. Have a wonderful evening. Thank you.
Thanks, Mr. Yang. And thanks, Mr. Yang, for make a very warm and exciting speech and to open our reception party for tonight. Tonight, we were prepared for our announce some new design to show with our friend, with our customer, our design, and to correct your view and to correct your comments for for our new design. And since we are in the shipping industry, we're together with the shipping man, and we have keep the change for always. And we keep the change in the ancient time. We changed the vessel from the boat to the steel. We use the more rigid material to build the ship. We keep changing the ship to more efficiency, and we keep the ship more safety for the crew. And also we provided a good environment, the protection for the ship. And also we face a challenge. And since we have the environmental protection requirement, new regulation will be coming and asked us to reduce the carbon intensity for the shipping transportation, for each transportation. We have the very new and very close limited time for the shipping innovation. And we have the reduce the carbon record for 40% will be in 2030, and we have reduced the carbon density in the coming time for the 2050. So always the challenge is coming together with the regulation required to push us to face this challenge. And of course, our shipping people is always very brave. We have a courage to face this challenge, and we know this challenge is very big, and we are not only use our traditional way and optimize our line and only improving our preparation way to improve. That is not enough. We face a big challenge. We need the courage to face this challenge. We understand the Greek ship owner is not only traditional, but also pioneer. We visit some ship owner, we collect some idea from their talking and communication we found, and Greek ship owner, why they can survive for 100 years or more than 100 years, because they are not only traditional, but also they are pioneer. They are beyond the traditional. So we prepare ourselves and to make some proposal, to issue the design, to let you know what we are research, what we are doing, and to keep our communication. After we have the presentation, we'll show you what we are seeing, what we can, the cooperation with you to support each other to overcome all the difficulty, to overcome the roof sea coming from the different direction or different view, not only the marketing competition, but also the environmental protection, the new regulation. So later, I will be arranging our Cssc group. So we are not only a shipbuilding group, but also we are ship research, ship design, and we consider all of the solution, not only for ourselves, but also for the owner comments. So after we introduce our each design, each consideration, we are waiting for your comments and waiting to receive your back comments, and then we hope we can provide more efficiency service, more proper products, more proper design to face the future, to win the future, to make the win-win situation for all of us. Okay, now we are coming the main course of this reception party, and we prepare the different shipyard and some design institute to make the presentation for their design. So now we welcome Mr. Li Xiaoping, the Vice President of the MARIC, to show their latest design, conception, and consideration.
Ladies and gentlemen, good evening. My name is Li Xiaoping from MARIC, subsidiary to Cssc Group. it's my pleasure to attend the Cssc reception party. So I will like make a presentation of new dual fuel Newcastle Max Barclay and VLCC we have development. So I will make introduction the following 5 items. So first, background. So as you know, the Paris Agreement required to control the temperature increase to less than 2 degrees. The IMO is always positive to reduce greenhouse gas emission to meet the Paris Agreement. So IMO the reduction goal is by 2030 is the carbon intensity reduction of 40%, but 2050 is about 70%. So different ships have different requirements. For container vessel, the MAC 74 had issued more stringent CO2 emission requirements for container vessel, and also have a different requirements for different deadweight. So for large bulk carrier, we are facing a more technology challenge to meet with phase 3. For decarbonization, so we have 3 solutions. So normally including the existing hull and propulsion efficiency solution, and another 2 potential solutions. For hull and the propulsion efficiency solution, most technology has been used, so such as line optimization and energy saving device, and also main engine derating. And some technology, new technology, are still under development. For example, air bubbling lubrication. And for alternative energy, so for example, for wind energy, so the system efficiency depends on the road. But the large bulk carrier is not fixed, is always, not always fixed road. So the wind efficiency is not stable. For alternative fuel, I think in short term, LNG is a practical and effective solution to meet with requirement, phase 3. So for other fuel, for biofuel and hydrogen and ammonia, maybe future solution to reduce carbon directly. So but they are still under test and study. So for dual fuel vessel, so Marik already designed the largest dual fuel container vessel for CMA 22,000 TEU container vessel. This vessel is under construction in Jiangnan and Fudong CBR from Cssc Group. So we use the WinGD main engine with a low pressure system, and also the engine tank is GTD Max 3 type with a capacity that's 18,600 cubic meters, located in the four part of the vessel on the accommodation block. So there are many challenges for technology in design, such as tank flow sloshing and reinforcement, and also long pipe diversion control, and so on. So now we have finished the detailed design, and this construction is on the progress smoothly. And first vessel will be launching at the end of this month. So next I will speak some words for dual fuel Newcastle Barclay, and we have German. And until now, America had already designed 2 generations of Newcastle Max Barclay. Up to now, the orders is about more than 60, so good record in the market. So we have applied any energy saving solution as far as possible to reduce fuel consumption, such as the whole line, the optimization, and also for efficiency proper, and ESD, and lightweight control. The final verified the EEDI value is 23% below baseline. So in order to meet phase 3 requirements, we have 3 possible solutions. Option A, so main engine derating, maybe the best is the simple way, but the vessel will not have enough power to maintain the maneuverability in harsh seas. Option B, we use several primary means, such as the shift generator, waste heat recovery, and air bubbling lubrication. All the methods to apply one vessel can meet with the phase requirement, but they are not mature enough for low-speed main engine. So option C, air fuel, is more realistic and not too much technical risk. And also the main engine also can keep to a safety level. So we have checked the delivery to Newcastle Max per carrier. You can see the typical route from China to Belgium or China to Australia, and some from the European to Belgium. So for air fuel tank capacity, so as a all carrier, so multiple carrier is not specified voyage road vessel. So all design philosophy is to cover the typical voyage route. So for example, from Brazil to China, we think the LNG capacity is more than 8,500 cubic meters. Considering the fuel rating and unpumpable, the tank capacity, I think 9,000 cubic meters is a good choice. So for LNG tank position, so for such large tank, it's a challenge to find the proper location. We need carefully considering the good balance, including hull strength, floating position, cost, and risk control, and so on. By doing preliminary hazard analysis, we think that the cargo hold area is the best position. The only disadvantage is the cargo hold capacity loss. We consulted with the owner and we have good feedback, and nearly 90% of the cargo is iron ore. So the hold capacity is not a very critical parameter for this vessel design. So we recommend the capacity tank for this vessel. So for LNG tank position, so we consider the tank located in the middle part. It's easy mooring for bunker vessel, but simultaneously operation is not recommended, especially for offloading due to high risk. So we have until now we have finished the first stage design, and we got 4 class AIP, including lowest, BV, DMVGR, and also ABS. So now we are doing the hazard risk analysis with BV. This will finish at the end of next month. So for gas system design, we have performed a fuel gas supply system design and arrangement optimization focused on the safety and cost. And all the fuel gas system will be located above LNG tank. So wind mast in the fore part of the vessel, and both are far away from engine room and accommodation block. So the risk will be reduced to a safety level, to reduce the lower level. So we also have done some preliminary OPEX analysis based on the lower pressure system and Type C tank. And the total initial cost increased, including the dual fuel engine and the generator and the gas handling system and LNG tank, and also steel weight increased. The total initial cost about $13.7 million. So this is the operation profile for the OPEX analysis. And from this picture, we can see in the eco split mode, the net present value will be positive only if the oil gas price gap is more than $130 per ton. That means if low sulfur oil is $500 per ton, the bunker gas price needs to be less than $7.2. So from this picture, for full speed, the NPV will be positive if price gas is more than $50 per ton. So from this we can see for large fuel oil consumption vessels, it's more worthwhile to use LNG fuel. So dual fuel vessel should be an attractive choice to meet with phase 3 requirements. So from our point of view, the best solution for dual fuel project is to secure the oil gas price gap. The oil company and the bunker company should be incorporated in the total chain. So next, I'd like to speak some words for dual fuel VLCC we have development. Okay, so until now, Mark had designed 3 generations of VLCC, and we have orders 30. So low fuel oil consumption and especially max cargo capacity with low electric well and by fully optimized core structure and strength analysis. So in order to meet phase 3 for VLCC, why use air-injected fuel? So if more main engine rating, that will also cause insufficient power for maneuverability in harsh weather. So I think that until now, air-injected is so far a good solution to meet EEDI phase 3. So this is a typical route of VLCC. For example, from Middle East to China, according to our calculation, the 7,000 cubic tank is enough. Another typical one from West Africa to China is a 9,000 capacity. If you consider to cover all the typical route from USA to China, the tank capacity will be 14,000 kilometers. And so all design consider to cover USA to Middle East. So we have 3 solutions. The tank capacity is 11,000 kilometers. So solution 1, we use 2 Type C tanks located on the main deck. Another solution 2 and solution 3, Type B tank and Mark 3 type. So we will locate in the cargo area. So the initial rest analysis is almost same as Newcastle max per carrier. However, due to its higher fuel oil consumption, the required oil gas price gap will be smaller than the Newcastle max per carrier. So we have done some preliminary comparison analysis. For solution 1, cargo hold loose, no cargo loose. Solution 2 and solution 3 will cost about 14,000 cubic cargo tank capacity loose. Some owners prefer a Type C tank on the main deck, and other owners insist LNG tank is more safe to be located below the main deck, and they don't care such cargo hold capacity loss. So we can provide all 3 solutions for different owners' proposals. So finally, I have 3 conclusions. The first point is for dual fuel large bulk carrier and VLCC. I think the oil gas price curve is critical for the OPEX analysis. So we recommend to have oil company, a bunkering company, to be involved to control the risk. The second point, even although in the cargo, the eco mode, the payback not very attractive at present, but the dual fuel is so far a good solution to meet phase 3 requirements. And the Marig, we had much more experience in the dual fuel design, for example, like container vessels. So I would like to be your preferred partner. That's all my presentation. Thank you for your attention.
Thank you, Mr. Lee. Good friend.
So Cssc good friend here. I'm from Starry. So today I give a presentation on our design towards 2030. 2030 is still far away, but as Mr. Lee mentioned, our shipment is very busy and very brave. As a partner in such shipping industry, we Starry is busy for R&D, and we are brave enough to face the future problems. Mr. Lee just now mentioned, we faced many emission limits, and we have many solutions or potential solutions for the future. We have so many solutions, but who will be the major player or the leading actor for the future? According to some forecast or estimation, maybe in the year 2050, when we have to face the problem of decarbonization by 50%, only LNG and ammonia has the potential to be the leading actors. Maybe LNG will have a share of about 41%, and ammonia has around 25%. So totally, these two leading actors will be about 66%. Considering present situation, LNG and battery would be very, very popular. But for storage, that's no big challenge. Already, the PCTC with LNG fuel and simultaneously battery inside connect to main switchboard is being built in Jiangnan shipyard already. And we will deliver our drawings for a ship driven by supercapacitor soon later. So my topic is on ammonia, methanol and fuel, and simultaneously we will give some solution for battery or hydrogen fuel cells. So we will give two examples of the future ship. Two for main engine at least, that's zero emission. And with the methanol, still we can reach the target for 2030. And the first one is a Green Dolphin, 180,000 that will test with ammonia as fuel. So you can see the tank ammonia containment system is here. Unfortunately, the capacity is much larger than LNG tanks. This is the main parameters of our design. A similar size as the traditional capesize, EEDI reduction is much lower. Actually, just considering main engine, that's zero carbon or CO2 emission. But up to now, no solutions for the auxiliary engine to burn ammonia. So for the auxiliary engine, still CO2 will be produced. And for the operation, Starry has this smart shift system. This can further decrease the energy consumption. But here we can see the ammonia's capacity requirement is much higher. So considering the weight, that's double times, 2 times of the fuel oil consumption. And that means for the same cruising range, the fuel cost is about 3 times of heavy fuel oil. So this is some features of our design. I only have 10 minutes. I don't want to read every word. So the advantage is zero emission from the engine. But disadvantage is bigger fuel tanks and higher capex. That's a low flash point fuel. So still from regulation point of view, we have to do something. Anyhow, our joint development project will be AIP by Lloyd Register. This is something about the containment system and the fuel supply system. This system price will be around half of the LNG supply system. The second one is the MR with methanol as fuel. Because this MR is majorly for methanol transportation, so that's easier for the containment system. You can use one pair of the cargo tanks, and simultaneously, if you like, you can have a deck tank with 2,000 cubic meters, or even bigger. Together with the methanol as the fuel, we can use battery to support the auxiliary engine system. the CO2 emission is about 10 tons lower per day than the conventional fuel oil, and the EDI will be around 44% less than the baseline. So no SOx emission. And for the charging and discharging of the battery system, you can get it charged by the auxiliary engine. And during import situation, if you have the AMP system, the battery can be also charged. For discharging situation, we cover the maneuvering condition and the waiting at port condition. So up to owner's requirements, we are very flexible to change the capacity of the battery and to define the right conditions, working conditions for you. The third one is the C-line 1400 TEU container vessel with fuel cells. Actually, this is zero emission feeder, but with some technology of direct current bus technology. Yeah, we are very flexible to combine different different electric power from various resources. Our target is for two trading routes. First one is from Hydraulic Canal, then to Baltic countries. The black line is for Netherlands, UK, Scandinavian countries. For the coastal or domestic operation, we think recharge of the battery and the hydrogen would be much easier. We have the liquefied hydrogen tank, we have the fuel cell module, and we have the fixed battery. But to make this design more flexible, we can use the containerized battery. Then that's, you can define your own shape as you like. How much power from the containerized battery. And with direct current bus to main switchboard, we can combine these power suppliers, and simultaneously we can even take into account supercapacitor to enhance the capability of increasing or decreasing the speed in very short time. So we can connect to shore power to recharge our battery. Also, we have the bunker station for liquefied hydrogen. This is some data, but anyhow, that can be very tailor-made for you. The battery is 2 megawatts hour, so 2 sets. So thanks for your attention.
Thanks for Mr. Zhou to make a very modern and future design. And then you can find we have 2 design institute. They have two type of consideration, and also we not only have the design institute, we are shipbuilding group. So we have a shipyard. Each shipyard they have a own design institute. They also have their own consideration. So we use this time to let them to present their design to you. Now invite Mr. Low and from Hudong Shipyard. Mr. Zhang from the Jiangnan Shipyard. Sorry.
Good evening, everyone. I'm from Jiangnan Shipyard. Today, I'd like to have this opportunity to say something about carbon emission in the next 5 to 10 years, their changes and our products. First of all, please let me have a brief introduction to my company. Jiangnan Shipyard is a member of Cssc. It was founded in 1865, the oldest shipyard in China. It has a total staff of total staff of about 20,000 people, and 50% of them are own employees. It has 2 dry docks, 2 indoor building berths, and 1 outdoor building berth. Jiangnan Shipyard is an expert of gas carriers and gas-fueled ships, has the ability of design full series of gas carriers. In recent years, the major products are container ships, gas carriers with Type C tanks, and gas carriers with Type A tanks. Now we are also looking for orders of gas carriers with Type E tanks, with membrane tanks and LNG-fueled ships. The turnover of last year is about 2.6 billion USD, and the current order book is about 8.6 billion USD. Jiangnan also has strong ability and favorable credit to get refund guarantee letters from the first-class national banks. There are 3 topics today. The first one is IMO strategy on carbon reduction. Then the next 2 are product lowering the carbon emission, Type B fuel tank for LNG powered ships, and the 4th generation of LNGC. The IMO initial strategy was adopted at MEPC 72 last year. It's consistent with Paris Agreement temperature goal to decarbonize as soon as much as possible within this century. The strategy aims to peak GHG emission as soon as possible, then reduce GHG emission at least by 50% in 2030, and reduce average carbon intensity by 40% in 2030 and 70% in 2050. IMO also plans to revise the strategy at MEPC 80 in 2023. May of this year, at MEPC 74, the application of EDFS 3 was accelerated and become more stringent. For ships shown on the slide, the application time was moved up to 2022, which is 3 years earlier than previous plan. And for container ships with deadweight more than 40,000, an additional 5 to 20% reduction than before is required. The 74th session also agreed to start discussing on introducing EDFS 4 with more stringent requirements. So, according to the information, the most possible application of EDFS 4 would be at 2027 and 2030, with 10% more reduction than EDFS 3. So we can imagine, in the next 5 to 10 years, to comply with EDFS 3 and Phase 4 will be a big challenge for new buildings. So for long-distance transportation ships, turn to low-carbon fuels, for example LNG, combined with reasonable speed reduction and new technology such as air lubrication, will be the most favorable approach to comply with EDFS 3 and Phase 4. This is the first product, the Type B fuel tank for LNG powered ships. In the recent 3 years, we have developed a very large ethane carrier for the market demand on ethane trade from the US to Far East. The vessel is fitted with Jiangnan developed brand-new Type B cargo tanks based on our experience of VLGC with Type A tanks. To face the carbon emission challenge, we enhance the tank design and make it suitable to carry LNG. We call it Type B fuel tank with brand-new technology, or BFT. Now the BFT is principally approved by ABS and LR. Compared with Type C tank, fuel tank, and membrane fuel tank, BFT has big advantages on volume efficiency, new building cost, BOR control, partial filling, LNG unloading, and maintenance, which make it a better solution to be applied on container ships, bulk carriers, war carriers, PCTC, and so forth. This is the application of BFT on mega container vessel. It's a joint project between Marika and Jiangnan. The fuel tank is located below accommodation island with a capacity of 18,000 cubic meters. By introducing BFT and LNG as fuel, the ship's carbon emission is reduced by 60%, predicted to comply with EDFS 4. Another application of BFT is on Newcastle-Max bulk carrier. The fuel tank is inserted into hull between number 5 and number 6 cargo hold, with a capacity of about 6,400. Compared with the conventional oil fuel design, The ship will have about 10,000 cubic meters less on cargo hold volume and about 1,000 tons less on deadweight. However, the carbon emission is far less than the oil fuel version. The carbon reduction is about 38%, compared with EDF phase 3. The second product measuring the carbon emission is the fourth generation of Jiangnan Panda, the VLGC4. Jiangnan has focused on R&D of VLGC for more than 20 years. You can see from the slide, the upgrade of our VLGC is mainly on enlarging the cargo capacity and reducing the air pollution emissions. The VLGC1 has a capacity of 83K, complying with IMO NOx Tier 2 and EDF Phase 1, burning heavy fuel oil. And the VLGC2 2+ has a capacity of 84K, complying with IMO NOx Tier 3, EDF Phase 2, and it burns no sulfur fuel oil or uses scrubber to comply with 2020 sulfur cap. And VLGC3 has a capacity of 86K, complying with IMO NOx Tier 3, 2020 sulfur cap, and the EDF Phase 3 by using LPG as fuel, not LNG, it's LPG. And VLGC4 is under development now, and its capacity is enlarged to 90K or even 91K. However, the LPG as fuel is not strong enough to support the vessel to comply with EDF Phase 4. So we introduced air lubrication system to further improve the energy efficiency and reduce the carbon emission. Here shows the main features of the VLGC4. The main particulars are almost the same with the normal VLGC. And the pendant design, this bow is applied to reduce the wave resistance. At the forward part of the hard flat bottom, several air bubble generators will be installed. By using air lubrication system, we can get about 6% net saving on propulsion power. And the manifold height will be less than 17.5 meters above water line to keep the same compatibility. LPG as fuel will be adopted the same with VLGC3. And besides bigger capacity and same compatibility, the carbon reduction is about 40%, predicted to comply with EDF Phase 4. Okay, that's all my presentation. Thank you.
Thank you, Mr. Tan. And you can find we have each shipyard, they have their own focus on the ship design and the ship products. But we have not only one shipyard, we have several. So next time we invite Pudong Shipyard, Mr. Low, to make their speech.
So, good evening, ladies and gentlemen. It is my turn. I'm from Pudong Zhonghua Shipbuilding Corporation. And today, my topic is for the energy carrier and container vessel for the environmental designs. Let me little bit introduce Pudong Zhonghua. Pudong Zhonghua is one of the core shipbuilding enterprise and the Cssc, and we performed expertise in LNG carriers and large arch container ships. Of course, we have LNG bunkerings, LNG fueling container vessels. And we have managed over 38 building assets. Annual building capacity reached 2 million tons. Also, we have in-house design capabilities. We already established ISO for the quality and environment, also for the health systems. Up to now, we have delivered 400 seagoing vessels. We have awarded Chinese industry great model in 2016. So this is, we call the Chinese Oscar. And my colleagues they already mentioned for the greenhouse gas emission control. So I will little bit mention here is compared to 2050, the greenhouse gas to be reduced 50% is a little bit far future, but if considered 2030 to be control the intensity by 40%. So this is now considered because only 10 years. This is the new effect for IMO for the EDR figures. This phase 3 to be effective in 2022, and for the non-vessels, gas carriers is 30% less than the baseline, but for the container vessel, you can see a big size will be directed to 50% less. So we can imagine, give some assumption, before 2030, maybe the EDR could be phase 4 and phase 5. So if each is 10% less, so that's meaning before 2030, will be more strict for the design. So just we think about the greenhouse gas emission. So how to develop the vessels for next generation. So first I will introduce our shipyard develop the LNG carriers. We call it G4 because in our shipyard we already developed and construction delivered 20 vessels for the engines. And this version is, we call it, is Generation 4 Plus. So this vessel, we still use the M96 L3 Plus membrane systems from GTT, and the boiler rate less than 0.1%, and the balance speed at 18 knots. The ship line was optimized the range from 12 knots to 19.5 knots, and the vessel is capable of more than 100 both of the worldwide terminals, and the vessel also have the ship-to-ship functions, and before the 2025, the rules we know will high. And the vessel will be equipped with STF, the wind engines, and the twin scale. And we also coating the low friction coatings. So EDR could be reached 50% lower than baseline. So this is our new development. And we also have the available options for this vessel. One is air lubrication systems, even can 2% improvement. And if shaft generates the EDR, also can another 2%. Also, the sub-cooling type liquefaction plant could be applied. This is also for the emissions. Next is for the container vessel. This is 15,400 TEU, the dual-fuel container vessel. We can, this one that we propose for the Type B and tanks, of course we can use the GT membrane type. So also we use the equipped with the we need low pressure engines and the shaft to be reduced to improve the efficiency. The whole line was optimized by service speed range and wide draft difference. So also we applied the low friction coating and some power saving device. And the vessel, now the EDI reached 63.5% lower than the baseline. So this is the baseline. We can also have some options for more improvement for the EDI. One is the air lubrication systems, and the another is the heat recovery systems. So heat recovery systems, for our calculation, for the power reduce could be 9 to 10%, but from the EDR calculation, only 2. So this is not an exact real situation. Another vessel is the 23,000 TEU dual-fueled container vessel. This is equipped Mass 3, same as the CFS EM. We already under construction. Same, we equipped with low pressure engines and low RPM, and the ship was optimized around the service speed, and the draft is different rate, and the low friction coating is same. So this vessel, the EDR could be 67% lower than the baseline. Also, we have some options to be. This is the same as I just mentioned. So this new developed the container vessel. We think this moment, if shipment place order, I think before 2030 is quite a good solutions. So that's my presentation. Thank you.
And Pudong Shipyard is one of the success for the NG carrier, and so they also have a lot of experience for the NG related. But they are on focus on the big container vessel and the big NG carrier. But now have another shipyard there. So we invited Mr. Kwai from SWS.
Good evening, ladies and gentlemen. I'm from Shanghai Waigaoqiao Shipbuilding. Today I will introduce dual-fuel vessels designed by SWS. SWS ship is environmental friendly with lower fuel oil consumption, better propulsion efficiency, and less pollution. Based on good design, SWS has delivered more than 400 vessels, include 65 VLCC, 38 Aframax, 46 Newcastle Max bulk carriers, and 218 Capesize bulk carriers. Now come to our new developed products, dual-fuel vessels. This is the design of dual-fuel Aframax. This vessel satisfies EDI Phase 3. 2 sets of Type C LNG tank are located in the cargo area on main deck. 2 cases have been applied. Case 1. Capacity of each LNG tank is 800 cubic meters. The endurance is 6,000 nautical miles. It is mainly for traveling inside Europe main ports. Case 2. Capacity of each LNG tank is enlarged to to 2,000 cubic meters. It is enough for double runs from Middle East to Europe. Moreover, fuel oil endurance is 13,000 nautical miles. As to dual fuel Newcastle Max bulk carrier, the speed is 14.5 knots, and the daily fuel gas consumption is only 36.2 tons. Very low. Two sets of Type C LNG tanks are located beside the accommodation area and the engine casing. Capacity of each LNG tank is 3,000 cubic meters. The gas endurance is 20,000 nautical miles. It is enough for double runs from Australia to China or for one run from PDM to China. And the dual fuel solution for Capesize bulk carriers are similar to the solution of Newcastle Max. As to dual fuel VLCC, the design speed is 15 knots. Two sets of Type C LNG tank are located in cargo area on main deck. Capacity of each LNG tank is 3,500 cubic meters. The gas endurance is 15,000 nautical miles. It is enough for double runs from Middle East to Far East. The dual fuel solution of Swiss Max is similar to the Aframax. SWS dual fuel vessels have received the Class AIP from ABS, BV, and Lloyds. Now I will introduce the fuel gas supply system. As we know, the gas pressure of WinGD XDF engine, main MEGI engine, four-stroke dual fuel generator engines are different. This is the technical characteristics of XDF engine and MEGI engine. We can compare with each other. Based on different dual fuel engines, different fuel gas supply system shall be applied. As to WinGD XDF engine, low pressure fuel gas supply system shall be applied. LNG fuel pump pumps LNG liquid to the vaporizer. The LNG is vaporized, heated, then supplied to the main engine via GVU. BOG from this tank shall be preheated, compressed by BOG compressor, then supplied to the downstream low-pressure gas consumers, preventing tankers from overpressure. As to main MEGI engine, high-pressure fuel gas supply system shall be applied. LNG fuel pump pumps LNG liquid to the suction side of high-pressure pump. The LNG liquid is boosted to 315 bar. The boosted LNG is vaporized, heated, then supplied to MEGI engine via GVT. One line at a discharge of LNG fuel pump shall be branched for the fuel gas supply to the dual fuel generators and the dual fuel boilers through the low pressure vaporizer. BOG line is the same as above. Compared with conventional vessels, LNG fuel tanks, LNG bunkering stations, fuel gas supply module including BOG compressor, low pressure or high pressure vaporizer, heaters, glycol water system, gas valve units, nitrogen system, and so on shall be arranged in the dual fuel vessels. Inward, SWS dual fuel vessels are optimized from the successful delivery record. NOx, SOx, carbon dioxide emissions are reduced substantially. EDI value is about from 35 to 40% less than standard line. That's all. Merci.
I think she made a very, very detailed and professional technical introduce. And unfortunately now we have a lot of the commercial people. So hope you can bring back and to study. And now we covered the big facility, big shipyard. So I know the Greek shipyard, we are not only big one, we have a 4 different size. So now we ask introduce Ms. Zhou and to make his consideration from Cssc shipyard.
Dear friends, ladies and gentlemen, thank you very much for joining this Cssc reception and presentation party. Personally, I'm very delighted to get the chance to stand here to review something about Cssc. In fact, I do feel that the right topic here to give to you is our design guys, but they have not got their visa, so I have to attend here. And my self-introduction were mainly on commercial and production side. So for the design issue, I will just mention, cut my speech as much as possible because those design house and big yachts, they have give you a lot of concept of the future energy, system. So Cssc is one of the 7 major Cssc group yacht, mainly doing the new building, ship repair, and large steel manufacturing. So the percentage of the business is 60% and 25% and 15%. With this good combination of the business, so for the last few years' time, Cssc has been running very healthy. So basically, as far as the new building is concerned, so we've got 2 facilities. One is called the Cssc Jiangling production base, where we have 1 slipway, and we've got Cssc Yangzhou production base. We've got 1 parallel slipway, which means we've got 3 slipways put together. The capacity to deliver ships is 20 ships a year. So the type of ships when we build, I think everybody understands, if they know Cssc, is we are more specialized on the bulk carrier side. And I have made a calculation. Overall, we have delivered total 230 ships. Out of these, 85% of these 230 ships are bulk carrier ships. I can give you some calculation. For the Diamond 53 ships, we have delivered total 63 ships. And for the Dolphin 64, we deliver another 63. For Kamsa 82 and 85, we total contract 32 ships, and we got 20 ships already delivered. So the rest of the ships which we constructed and we have delivered on the niche market. First of all, also I would like to mention about the self-unloading ships. This technology and experience is really improved by Cssc itself, thanks to our ship repair and conversion capability. We have total delivery more than 12 new building self-unloading ships, and we have also delivered 7 pitch carriers. And presently we got another 8 wood chip carriers under construction. And then next I would like to just mention a little bit, about the ships mainly we are building. This is called 82,000 bulk carriers. We rely this one on our sister company of Starling, and this is actually the 4th generation of the ships with a very typical length 229, and you will see the draft on the design draft is 12.2, and with scanning draft is 14.5. And this ship is compliant with EEDI phase 2 requirement. So if we back this ship, we have total delivered 20 ships. If we back to these, we call 85 series. This ship, we have contract 2 ship. This is also designed by Starry. And you will see this ship is got slightly bigger breadth, is 36 meters. Then you will have quite a shallow draft, 11.5 compared with 12.2. And for scanning draft is 13.6, that one is 14.2. And oil consumption here is a 26 plus, for 82 is a 23 plus. This ship, this type is also compliant with EEDI phase 2 the regulations. So then also I was assigned to give you introduction about Cssc own design. Now, I would say majority ships we rely on our group internal design house, and some of that we use outside engineering company. A little also done by myself. I have just mentioned about selling on ships. So since the last 5 years' time, Cssc has been working very aggressively on these MR ships design. Everybody understands that GSI is a major player for the MI construction, but do not forget, Cssc is also substitute power of the group for building these ships. And this design actually is the Cssc jointly developed with the Korean design house. I can give you some of the parameters you will see. This ship, the length and the breadth is almost the same with similar ships, but if you see the oil consumption, you will find if the ship goes for 14 knots, the oil consumption is 18 plus. If the ship goes to 14.5, it's only 20.7. It's very good oil consumption. And especially this ship is compliant with the EEDI phase 3 project. So currently we have 2 MR ships under construction. It's a 56,000 day rate, also with a wider beam. That is a 36 meter wider beam. And this one, we are yet to take the orders. We are working very active. So if people are very happy with Cssc, so we can discuss face to face. I would like to give you a good offer. Thank you very much.
Thank you, Jason. I'm very proud and as a commercial team and the people can make the technical presentation, and we are very proud. Thank you again. So now we have the shipyard moving to the south of the China. So now we welcome Miss Huang from the GSI to make speech.
Good evening, everyone. Being here will give me a very pleasure. I'm from the GSI, Guangzhou Shipyard International Company Limited. This time, I would like to share our latest design for the MR tanker and LR2 tanker with you, all of you. Both MR tanker and LR2 tanker, I would like to present from the 2 points. One point is energy saving solution, and another one is friendly environmental solution. That means the least can impact on the environment. For the MR tanker, we know the GSI has very focused on the MR design and construction. So before we optimize all the MR tanker design, we just think about what the market is needed. For example, we communicate very close to the market, and we know what the exact demand from the market, from the ship owner, and from the operator. Finally, now we have these solutions from our shipyards. This is this year's very new design. Please note here we have this scattering draft. The scattering draft is only 16 meters, So this is compared with very conventional 16.3 meters. That means we had a very shallow draft for this. This shallow draft we can attain this dead weight around the 15,000 tons. And another very different compared with the old design is this capacity. Now we discussed many times with the owner. So now we have this very large cargo capacity is up to 58,000 cubic meter. This you know we have the actual 4,000 cubic meter compared to the old design. This is I think this design is very different with the other design. Here, this is the general arrangement we can see here. And also, not only we have the very large cargo capacity, but we're thinking about how about the fuel oil consumption. This is the benefit for the owner. We have these 2 points. One is we just optimize the whole form to think what we can do to lower the resistance, and another one also from the whole form optimization to have the higher propulsion efficiency. During the design, we're not thinking about the resistant performance in the calm water. We know the vessel is not always sailing under the calm water. Most of the cases, for example, maybe more than 80% of the cases they were sailing in the heavy weather. That means we need to consider all of this. So this design, we just think about this one. The basis is for Cssc, we have more than 100 MR tanker has been designed and delivered these years. So that means we have the perfect database from all these designs, including the data from the model test, and also we have the many data from the sea trial, the full scale, the sea trial including some for example, Build 4 or Build 5 like that. So this is very useful, the database, for our further optimization for our for home. During the design, we have the optimization. First, use the CFD. Several cases we have investigated here. We just show you there are totally 3 cases, but in act, not only 6 cases. For the case 0, this is what we have, the current ships, and for case 1 and case 2, this is what we selected to the presentation. You see from here, we know for the wave making resistance, for the case 2 is very good compared to the case 0. And also, we investigate the viscous pressure jacks. What about for all these cases? For this case 2, compared with this reference vessel, is very good. From the CFD, is even up to 20% of the reduction from the viscous pressure drop. And here, this is a weak field. Of course, we can this weak field is more uniform compared to this. So that's why we can have a higher propeller efficiency. What we have is we not only do the CFD calculation, we also do the model test. The model test has been carried just 2 weeks ago at the SSRI and Shanghai. So the result is highly in line with what we predicted in CFD. this is the result only. This is for the design draft. Of course, we do not only the design draft, but also the scheduling draft and ballast draft. And for here, we just say what about the compared to our GSI's old design from this 2012 we use as a benchmark. We can see if we just see the per deadweight, the fuel consumption. Now this is the saving is more. That means the less fuel consumption. But if we look at this one, we know we have the larger cargo capacity. That means if we taking account the barrels, the fuel consumption, this new design is very, very good. Just mentioned, we not only think about the resistance in calm water, we pay more attention to the resistance in the wave condition. So from the safety, we have the around 8% reduced compared to the old vessel to have the added resistance. And also, we not as GSI not only just think about the whole form optimization. We never forget the society, the social responsibility to reduce the emission, to reduce the impact to the environment from the ship. So we have the joint work with DNVGL. So to use the LNG as a fuel to see what will happen to for this MR tanker. And this is what we investigate the route for the MR tanker. The typical route is from the Europe to the North America. With all this, for example, the tank capacity, LNG tank, we are based on all this route. This is the LNG design philosophy. And for the LR2, we do the similar work to, for example, the whole form optimization and for this LNG dual fuel. It's a good news for us. For this MR dual fuel, we have attained the DNVGL's AIP. So I would like to have this opportunity to invite DNVGL to come here to present the AIP statement to our shipyard. So please, Mr. Nicholas. From DNVGL and Mr. William Zhou from our shipyard.
First, I want to thank Cssc for the invitation. So, as Mrs. June present, we have made this joint work with them, and we're proud now to present this statement for approval in principle to Mr. Zhou.
Thank you.
Σηκώστε λίγο πιο ψηλά, λιγάκι πιο ψηλά.
One more thing, I believe. For GSI, I believe our problem is not how to build LNG fuel ships. Our target is how to reduce the cost, so we can make most of the clients are able to offer these kind of ships. Thank you.
Thank you very much.
Thank you, Ms. Kwan, and also thank you, William Zhou. I think now you always show the GSI always have a good commercial people that technical. now we We are coming to the next and welcome Mr. Li Xi and to coming from the Prokopyu to make the presentation.
My friends, good evening. I'm Li Xi from Prokopyu shipyard. So I would like to take the chance to introduce brief about our shipyard. We have 3 yards. One is in Changzhou yard. This is Changzhou yard. This is Wenzhong yard. This is yard in Longxuan. So we have 3 yards. So now we are building Bulgaria, Kamsamax, and also mini cape. And at the same time, we are building the feeder container ships. And it includes 1,400 dual-fuel container ships, and 1,500 container ships, also 2,700. So up to 3,500 container ships in our shipyard. So every year for the feeder container ships, we delivered about 20. So we are focused about the feeder container ships. So we have some, for dual-fuel container ships, we have delivered 4. So it's the 1,400 container ships. So now we have a new design, special for the 1,900 dual-fuel container ships. And so for this ship, it's clean and no emission. Because so we have the tanks behind the bridge. So the capacity of the tanks is 9,000 cubic meter. It's possible for 9 days. So the fuel consumption is, for the gas motor, it's 31.7 tons. For diesel motor, it's 39 tons per day. So I think it is all focus is for the owner would like to reduce the consumption of the less consumption of the fuel. Also, it's very important is the high cargo capacity. So for this size, the 14 tons containers is possible. 1,260 containers. And it's low. All design for the bow is the vertical bow, so it's low resistance. And because a lot of the shipyard have mentioned about the year 2030. And because all the yard also include, we discussed with a lot of owners, they are very interested to find a solution, dual fuel, because this is the one way to have the big challenges for the year 2030. But I think this is the one way, because we have a delivered ship. Now the ship is operating in broad sea. It's get the owner is very satisfied. So we have another option for the year 2030. Because another way is I just mentioned a lot of yard we think we can use LNG as a fuel. Another way is we just reduce our speed and take more containers. This is another way. So we have our new design. It's blue whales container vessels. So we will have take more containers and low speed. So the service speed is 18.3 knots. And it can take the containers and 14 tons, 2,600 tube. So these ships, we think is also good for the year 2000, for the challenges of 2030. So it's, we have designed for these ships. And it's according to the new rules. And the second is less fuel consumption. Also for the it's low resistance hull. Also the third is high cargo intake. So 83%, 14 tons containers loading load. So clean, so it's tier 3 and scrap. EDF is 3, close to 50% reduction from the baseline. Also smart, so energy saving. So for the future container ships, we also is thinking it must be smart. And on the year before last year, we delivered the first smart ship to the market. For this ship, we also have get to the AIP from DOA. So I think it's possible to build it immediately. And for the year, we are thinking about the future, because not only 2030, also 2050. So we have our design 1,000 power battery container vessels. So we would like to put the battery, but this picture is not so clear. We put the battery just separate, separate the battery. And it's for the safety of the battery, because we don't want to just connect all the battery in one place. We put one different place, but also it can save the cable for the. So because this ship, we believe it's zero emission. Also, the power battery supply all the loads of the vessels. Power safety, smart power control system, and the new fare control system. I have mentioned this battery will put on different place for the safety. Also low cost. The electric charging is low than the fuel oil. And easy maintain, because this is without the diesel engine, so it's more easy to do the repair. So we believe this is the ship, is the future. And now electric car is more popular, so we think this electric vessel will also be very popular on the year 2050. And another idea is about this. I think is our idea because this is the map of Europe. Because now how to charge the power to the electric battery vessel. So our idea is because now there are a lot of wind farmer. This is our idea. Wind farmer, because we think for the wind farmer it's possible to make the charger station. This is easy for the ship to charge the power. This is the one way for the charging of the container, electric container vessel. Second is, I think it's possible to use the charge. Now we use the bank, oil bank, energy bank. So maybe for the future, it's electric bank. Also, it's possible to service, to charge the battery container vessels. So this is our idea. We think this is our future. Thank you.
Thank you, Mr. Lee. I think after we have make the presentation from the two design institute, and then we have 6 shipyards make their own design and consideration. Some is very future, some is very realistic, and some is considered based on their shipyard view, and some on behalf of the ship owner. And I hope they are introduced not to make confused for all of the ship owner, and then you will come back and will see, I don't know how to select the future ship. And today we cannot make the full design or detail to them, but we provided some idea and to show you. And as a Cssc group, we have a ship design, we have a shipbuilder, a shipyard, but this is not enough. We have a finance support. We have the leasing company. So now, welcome Ms. He to make the presentation.
Ladies and gentlemen, good evening. So you have been presented by the best institute and the best shipyard with all their best designs. Now you must be thinking how to make these designs become your true fleet. So we are here. That is why we are here. Cssc Hong Kong Shipping Company as the financial branch in the group to support all the projects in the group. So there are generally 3 major structures to go. First one is the financial leasing. If you are looking for pure finance, under this structure, we provide you with the finance. Comparing with the bank finance, you can get higher leverage and also the more flexible financial covenants requirement. This is also quite important for all the companies to move flexible and to the future. Second, we have operating leasing structure. Under this structure, if you are looking for chartering the vessels for long term, but you don't want to hold the assets in your balance sheet, so we provide this structure. We build the vessels according to your requirement, and then you can control the tonnage and operate the vessels for long term. Then we can also offer the joint venture structure. If you have your business ideas, but you need an equity share partner, we can be here to establish joint venture to build the vessels together and to operate the vessels together. These are the 3 major structures we are here to go for the new projects. Creative, flexible, and reliable has been the top 3 elements for our company during our short but very fast-growing business history. So we are here also looking forward to produce and create more business with our new friends and with our old friends. I'm the marketing director of the company. So if you have your ideas, want to share with us for further discussion, I have my name cards for you. Thank you very much.
So I say the money is so important. So technical is a base, shipbuilding is a way. The money is a solution. So today we provided use long time and more than 1 hour to show you and what we the Cssc solution. And I know, and now is not too late, but I still want to use a couple of minutes to give you more impression about the Cssc group. So we show you a very short video, and then keep this one in your mind. This is our Cssc group. Come on. Finish our presentation for today, and we are very happy to get all of friends here. And after the presentation, we have offer a very nice dinner and food for serve for all people. Enjoy the time, enjoy drink, enjoy your friend, enjoy the future against the Loop C when we sing it. Thank you. Thank you for all this.